What's going on, everybody? This is the connected video to identifying a redox, where we're going to be doing example problems, trying to figure out what is oxidized and what is reduced in 3 separate example problems, and this will give you some good information for the next worksheet. But let me get this camera a little more focused. That bottom is looking a little blurry. See if we can fix that. All right, a little bit better. We'll stick with that. So just like we did before, the best way to start is going to be to list out, and I'll actually do it in the middle this time. I'm going to list Zn and I'm going to list H, and we're going to figure out what their charges are on each side of the reaction. And we're going to use our same set of rules that we used before. So on this left part of the reaction, we would have zinc. Zinc is currently alone. It doesn't have any charge with it, which means its oxidation number must be 0. You can do plus, but it's just 0. It doesn't have any oxidation number because it's not sharing any electrons. Hydrogen is sharing electrons, but it's sharing them completely evenly with itself on the right side, so we know that must be 0. And then for the other ones, we know that their oxidation number is going to be equal to the charge. Zinc has a 2+ as a charge, which means it must have become a +2 as an oxidation number. And the hydrogen has become is a plus on this side, which means each individual hydrogen must be +1 over there. We then follow our rules of oil rig, or, which if you prefer, Leo says Ger. Whichever one you are preferring to use. Oxidation is loss of electrons. Losing electrons is oxidation. So in this case, our zinc has lost electrons because it has become more positive. So zinc is oxidized. Reduction is gain in electrons. Gaining electrons is reduction. So this is gained an electron because gaining something with a negative charge would have reduced it to 0, which means hydrogen is reduced. So the first two we're going to do are pretty straightforward, but this is the approach that you're going to take. You're going to figure out what the charges or what the oxidation number is on each side, and then you're going to use that to tell which one was oxidized, which one was reduced. Okay, next example. We've got Al, and we have Cu. And I don't even think I did it this way last year with like the little table underneath it, but this is just what's feeling good this time. It's what I think makes sense. So we're gonna stick with this. This seems like a good strategy. First thing, we have no charge with the aluminum, no charge with the copper, which means our aluminum must be 0 and our copper must be 0 on their respective sides. Then our copper has a 2+ charge, so I've got a 2+, which is a +2, sorry, to write it the correct way. Our aluminum has a 3+, which is a +3, so that one was pretty straightforward. Again, we ask ourselves either Leo oil rig or Leo says Ger, or I guess you could flip it, you can do like Leo rig or oil Ger, but that's a little bit weirder, I guess. But oxidation is loss in electrons. What has lost electrons? Well, that would be the aluminum because it's become more positive, and since electrons are negative, so aluminum is oxidized. Reduction is gain. Copper has gained 2 electrons, so that means Cu is reduced. All right, last example is one that's going to be a little bit more complicated. So in this specific one, we've got our carbon, we've got our oxygen, and we've got our hydrogen. We first ask ourselves if any of these have a rule, because none of them really are by themselves except the hydrogen. Well, we know oxygen must be a -2 unless it's with fluorine, and there's no fluorine. We know that on this side, the hydrogen is by itself. It's got a charge, so its oxidation number must be equal to that charge. And now we have to use our critical thinking skills to figure out what each of the pieces are. So in this case, we have our carbon over here. Carbon's got a negative, or is attached to 3 oxygens, and that totals to a 2- charge. 3 oxygens, so that would be 3 times -2 is a -6. So what number must carbon have? Carbon must have a +4 oxidation number to cancel that out. And then if we come over here, carbon is with 2 oxygens, so that's a -2 times 2. What thing would cancel out with our 2 times a -2? Well, it would be a +4. And then over here, what number would cancel out 1 -2? If you've got 2 hydrogens, that would be a +1. Now notice all our numbers stayed the same. And so what does that mean? That means there was no redox. Because none of them changed, there was no oxidation, there was no reduction. So even though a chemical reaction occurred, it was not, in fact, a redox reaction. And that is an option. So you have to be on the lookout for it. Don't feel like you're doing something wrong. Although I assume you might have if you attempted this by yourself. You'd probably feel like you did something incorrect. But no redox is an option. If the question asks what is oxidized, what is reduced, in this case you would say none of them. There is no redox on this example problem. All right, those are the 3 examples I've got for you today. We can do more in class, and if you got any questions, send me an email. Otherwise, this is Mr. Diamond signing off. Have a great rest of your day, everybody.